So this is an example of Dijkstra's algorithm again. So it says find the shortest path from one vertex to another using Dijkstra's algorithm. All right, so it says find the shortest path from A to F. So we're going from A to F. So step one, draw in A in your first row, like so. And draw all other remaining vertices as your columns. Doesn't really matter what order, but I always try to have your finishing vertice last. All right, your next step is you need to draw in the length between each of these vertices. So for example, from A to B, there's a length of 2, so we copy in 2. A to C has a length of 6, so we copy in 6. A to D, D's over here, so there's no direct connection between A to D, only via other vertices. So we put a cross in there. A to E is also the same. A to F, there's also no direct link. Next step, we need to put a box around the smallest number in that row, which is 2, all right? That is in column B, so we bring the B down into our row, bring the 2 down with the box around it, and we repeat again for our second row. It's a little bit different, so just pay attention to a few things in row B. So B to B is done with 2. B to C, all right, with connection there. B to C has a connection to 2. So this is where it's a little bit different when we get into our second row. Now what we need to do is take 2, for this one here, and add it on to the box number from the last row, which was this one here of 2. So 2 plus 2 equals 4. Now, since that is less than the number above it, 6, we keep the 4 and we copy the 4 into this row. Right, now we look at B to D. B to D, there's a connection of 3. Once again, 3 plus the boxed 2 equals 5. So we're going to put 5 in here. As there's no number above it, we just put the 5 in. B to E, connection here of 2. So 2 plus 2, we get 4. So let's copy our 4 into that column. B to F, no direct connection. Look at the value above it. It's an X as well, so we put the X in. All right. Look for the next smallest box number. You'll see that we've got 2, 4 and 4. So what we need to do is we can pick either one of those. I always work left to right. So let's box the 4. Let's bring that down. Box around it again. It's in column C, so we bring the C across and bring down any other box numbers. So we have the 2. And we repeat the process again. So from C to D, is there any connection? C to D, we've got a 1. So we're going to go 1 plus that column box that we just brought down, which was a 4. So 1 plus 4 equals 5. All right, look at the number above, it's the same. So we're just going to put a 5 in there. Then we go C to E. Is there any direct connections? No. There's no direct connections from C to E, so we're just going to bring down the number that's above it. So 4. What about C to F? No again, and we put a cross. Cool. Now we repeat again. We put a box around the number in that row as it's finished. Smallest number's 4. Bring that down. Box around it. It is in column E, so let's bring out E across and bring down any other box numbers that we may have. Cool. Repeat the process. E to D, is there any connection? Yes, 2 plus the box number we just found, which was 4, is 6. All right. It's bigger than the number above it though. So, because the number above it is smaller, we're going to bring that 5 down. Okay. E to F, is there a connection? 3. 3 plus 4 gives us 7. And we haven't got a value above it, so we are going to bring that 7 in. Cool. Row's complete. Find the smallest number. It's a 5. Bring the 5 down. Box it. It's in column D. Bring the D across into our new row vertex and bring down all the other boxed numbers. Make sure you put a box around them so you don't lose track. Now we're going to finish off this row. So D to F, we can see D to F is a value of 5. 5 plus the previously boxed number, which was D, which is 5, so that equals 10. 10's bigger than the number above it. So we're going to bring down the 7, and 7 is going to hold its place just nicely there. All right, it's our last number. We put a box around it. So we are finished completing the boxes there. Now we need to do one of the last steps, which is backtracking. So we're going to start at the finishing vertex. Right, in that column, we know that we want to finish at F. So we look for the column F, and there it is. Start there. Now, it's a number 7 in that box, so we're going to draw a vertical line up to the last 7, which is here. And we look at the row that is in. It's in the row E, so we're going to draw across till we get to column E. Get to column E. It is a 4, so we draw up to the last 4. Right, this is called backtracking. We get to the 4, it is in row B, so we're going to draw across till we get to B, column B. We're in column B, draw up to the last 2, and then across to our finish. Right, so we've completed the backtracking. Now we need to take note of the vertical lines in each, not the vertical, the horizontal. So let's see, we've got A, there's one horizontal line in row A, then we've got a horizontal line here in B, then we've got a horizontal line in E, and then we finish off with our finishing vertex, which is F. And the value of that finishing vertex in that box is the length of our shortest path, which has a length of 7. You guys have just done Dijkstra's algorithm.